Hey guys, welcome. This is our 8.3 video. We're actually finally in to what we call trigonometric ratios. So these ratios are ratios that exist within a right triangle, so it has to be a right triangle. And those trigonometric ratios, we have three different types, and we're going to be using these a lot. And this is the foundation of what, when you hear Algebra 2 trig is referring to these three types of ratios, and all they are is ratios. So if you think about the last chapter, chapter 7, we dealt with a lot of ratios, one thing over another, so it's a fraction. And here we have sine, cosine, and tangent. And a lot of times we abbreviate those in a shorthand term, and we'll see that as we get going. And this is going to be the most crucial thing for this section. You need to have a calculator. Without a calculator, these are very difficult to do, impossible, unless you have the old school way of doing things, which was you would have a chart. And so we're not going to be using a chart, but we will be using a calculator, and it has to make sure it has the sine, cosine, and tang button on it. So I think you can see that where it says sine, cosine, and tangent. So you'll need those. So first of all, make sure you write this down. This is very important. And we actually have a shortcut way of writing this. So you need to write both, but we call this so. We call this ka, and we call this toa. Okay? So you might be like, what? Why is it so ka toa? Well, here's the trick. Okay? So if we look at angle A down here, A is opposite over hypotenuse. So see how the O is for opposite and then hypotenuse. So opposite, hypotenuse. So there's the OH. Adjacent and hypotenuse. So adjacent means it's next to the angle. So if you look at A, B is right next to it. That's why I put B there. And then the hypotenuse is always the same, C. And then TOA is opposite over adjacent. Okay? So we have this thing called SOHCAHTOA. TOA. Just so we have that a little bit better, I want you to write this down as well. And we're going to go SOHCAHTOA. Okay? And we have our special names, or what we call them, is going to be sine, cosine, and tangent. Okay, so we shorthand them as sine, cosine, tangent. We don't say sin, cos, or cos. Okay, and tan, we usually sine, cosine, tangent. Okay, and then we'll fill in our other piece. Let's do green. So this is opposite, and this is going to be hypotenuse. This is adjacent, and this is hypotenuse. And this is O for opposite, and then adjacent. Okay? So we're going to go ahead and utilize that. So I'm going to flip that back around, and let's go into our first example, writing a trigonometric ratio. So here we go. And so it says, what's the sine, cosine, tangent of t? So the first thing I'm going to do every single time, so write this out please, but first thing I always do is I write this at the top of the page. This is my gold standard, my bread and butter, if you will. Always want that. So it says for t. So I like to use what's called googly eyes. So I put the googly eyes right here. So I'm looking down at angle t, and I'm saying, all right, what do we got? So I'm looking from the perspective of t, what are my different options? So first, let's go ahead and do sine. So we're going to get sine. So the ratio for sine at t is going to be O, opposite. So opposite of t, okay, opposite of t is 8. That goes on top. And then the hypotenuse is always the same. It's 17. Okay? Pretty easy, right? All right, erase that. Let's go to our next one. And I'll do orange for cosine. Okay, again, looking from the perspective of t, adjacent. Now, from t, 15 and 17 are both right next to where the angle t meets. But 17 is always the hypotenuse, so it has to be the adjacent one is right here. So that's 15 on top. And then the hypotenuse is 17. It always stays the same no matter what angle we're looking from. Okay? And last but not least, let's go with our tangent. Okay, so we got tan equals, so again from tangent, I'm going to do opposite 8 over adjacent 15. So there they are. So katoa using our trig ratios to help us set these up. Okay, let's go ahead and look at 2 more problems and we'll call it a day. Alright, so here we go. We're trying to find the value. Now if we take a look at trigonometric ratios, we haven't actually talked about what they do yet, but they help us find side lengths and angle measures in a right triangle. So if you look at this picture right here, we have Pythagorean theorem, which I only have one side, so I can't use Pythagorean theorem. And then I have special right triangles. Well, 90 and 54 is not a special right triangle, so what we can use is a trig ratio. So to do this, the first thing I want to do is make sure you write this picture, but we are going to go ahead and write out our gold standard, okay, so katoa. And we're going to start by putting our googly eyes at the angle. We always want to focus on the angle, okay? So looking at this angle, what 2 pieces do I have? So from 54, we have W, which is an opposite side, and we have 17, which is the hypotenuse. Okay? So those are 2 things I have. So which should I use? So katoa, which uses an O and an H. Your answer would be sine. So we're going to do the sine of 54. So you always take the sine, cosine, and tangent of an angle, and then you set it equal to its ratio. So the opposite is W, that goes on top because it's opposite, then hypotenuse. Okay? Now we solve. To get that 17 from the bottom, we're going to go ahead and multiply 17 out. That 17 cancel out, so we get W equals, now 17 times sine 54, now we're calling in the big guys. Here comes our calculator. So I'm going to go ahead and punch it in. Let's increase the size. Okay, I guess that's not too big, but we'll make it work. Okay, so I'm going to just type in 17, hit the sine button, and then 54. Okay? So there's a couple secrets to this we'll have to talk about more in class, but hopefully you guys can see that. So I did 17 sine 54. Now on my calculator there's a little d up there, meaning I'm talking about degrees. We'll talk about that in class. That's how your calculator has to be set to get this right. Just hit enter. Calculator does some thinking, and we come up with 13.75. So that's our answer, 13.75. So W is approximately 13.75. So trig allows us to use these set ratios in all right triangles that exist, and it allows us to go ahead and find other sides. So here we were given a side and an angle besides the 90, and we were able to solve. So trig also allows us to do another thing, which I'll show you guys right here by going to our next problem. Oh, my face is really big. Let's go ahead and make me a little bit smaller. There we go. Okay, so here's one where I don't have an angle and I'm trying to figure out an angle. Again, my first thing is so katoa. You should never get bored of writing this down over and over again. Okay? It is how we figure out everything. So it wants me to look from angle X, so I'm going to put my googly eyes on angle X. Okay? And for my googly eyes, it looks like I have the opposite and I have the hypotenuse. Okay? Which means I'm using sine again. OH sine. So we're going to do sine equals, oh wait, we made a mistake. Normally we were supposed to put a degree here. Guess what the degree is? I don't know. So this is an unknown variable. So let's go ahead and call it A for angle. So we'll call this sine A. And we can put in parentheses if you like. It makes it look nice. And then we're going to put opposite over adjacent. Okay, how do I do this? Well, I want to get a alone. To get a alone, I have to get rid of sine. To get rid of sine, you do what's called the inverse of sine. So, all right. Again, let's go ahead and use our calculator. So I'm going to expand my picture. Okay, I'm going to zoom in here, or not zoom in, but if you take a look at my calculator, there's the sine, cosine, tangent. Now right above it, you see sine -1. That's inverse. That undoes or is the opposite of taking a sine. So if you do the inverse of sine, it's sine -1. So let's go ahead and do that. So if I take the inverse sine of both sides, it's actually going to cancel this out, the original sine we have. So over here I could take sine -1, that's the inverse of this side. And what happens is it cancels that out. And so I'm left with a, and whatever I do to one side of the equation I have to do to the other. So that means this is going to become sine -1 of 6/10. Okay? Again, I'm going to take my calculator out to get to the sine function. An inverse sine is different on everybody's calculator. But I'm going to go ahead and show you what it looks like on here. So there's sine, see that -1, that's the inverse. And then 6 divided by 10, and it's in that parentheses. So we just hit enter. And that is the degree measure. So 36.86. Okay? So A, this guy right here, equals 36.6. And I'm going to put a degree sign on it because I know it's an angle. Okay? So we know that it's an angle. Alright. I say we do one more. I'm going to do this next one a little bit faster though, so be prepared to slow me down. Let me get my face smaller. Again, I'm kind of creeping myself out here. Let's do one last problem. Okay. So I'm going to go turbo mode. Check this out. So, from the y perspective, so googly eyes, I have opposite, and this is not the hypotenuse, so it's adjacent. OA, 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 TOA, that's going to be tan. So I'm going to take tan of, let's call this, let's call it x for whatever reason, degrees. I don't know what that is, that's what they're trying to have me find. So we'll do tan of x equals OA, OA, that's going to be 100/41. Alright, now I got to get x alone, so we got to get rid of the tan, so I'm going to go ahead and do the inverse tan on this side, which will cross that out, leave me with x. Whatever I do to one side, I got to do to the other. So this is also going to be tan -1, or the inverse of tan, 100/41. Take out the calculator, and inverse tan, 100 divided by 41, and I get 67.7 degrees, because we're talking about an angle. And I'm out. That's it. Alright, so good job. I think there was supposed to be like an extra credit opportunity or something. Okay. I gotta make it hard, because you guys, I feel like you guys have been getting away with some pretty easy extra credit. What if you had to do like some research or something? I'm gonna pause the video real quick. I gotta think. Okay, I got it. Bring in a baby photo, or like a photo when you're younger. Okay? It could be on your phone. That's fine. You just gotta show me. Sound good? And if you don't have any photos available, like at all, like for whatever reason you just don't have any photos, then draw a baby version of yourself. It has to look like you put effort into it. If it looks, I'm no credit. Okay? Alright. Peace. I'm out.